Good morning, everyone. Am I audible?
Yes, ma'am.
Yes, good morning. So, our chief guest is joining with us. Good morning, Mr. Jawahar. So, Mr. Jawahar has joined with us. So, we are really happy to have you in this at Makeathon, Make and Codeathon 2020.
Yeah, thanks, ma'am, for
Mr. Jawahar is my own friend. We have been associated from 1997. Currently, he is working as a project manager in Nokia Networks. He has a wide knowledge in all this IoT relevant stuff, wireless technology stuffs. And one thing is, he's a keen adventure. He loves to travel across many places. So I think he may share these details in person to you guys. So warm welcome, Mr. Jawahar. So now I think the first team, Arun, your team is ready, right?
Yes, ma'am. We are ready.
Yes, so over to you. Just have you prove yourself that you learned a lot in this IoT and utilizing this make and codathon and make it a grand success. We are having Dr. Mohana N here, who's a coordinator in making this event a successful one. Warm welcome to Ms. Dr. Mohana as well. So over to you, Arun. You can take the lead.
Yes, ma'am. Is my screen visible, ma'am? Hello. Hello, ma'am. Is my screen visible?
Yes, Arun, it is visible, Arun.
Yeah. Good morning, Mohan ma'am and Jawahar sir. Uh, this is Arun Kumar and my teammate name is Yamini. Now, our project is about and developing a spy drone which has special features that and detect the illegal drug plants, which is useful for the government sector. Let's get into a detail about this project. Till now in India, even they are performing lot of activities to stop growing these psychoactive drugs, but majority of these drug sales have been going on in India. But we need to reduce growing these psychoactive drugs. So we just introduce this product, Spy Drone. This product has an inbuilt feature that detects and classifies the plants which is safe or harmful. So once this drone has a controller can be visualize what are all the this drone is going to do using some vision sensors and some AI algorithms. Here we are going to capture the image using vision sensor, and the captured image is being classified using AI algorithms. So after the classification, if we identify any drug plant, the drone itself has an automatic feature which save the photocopy of the identified drone. Identified the drug plant and the location of the identified plant, and those two details have been saved into the database. Even the controller can explicitly enter the details like adding the location of the plant and some other details. So after identifying, so we can perform another further task to stop this growing of the plants. Major issue in deploying no the major aim is the manpower is not efficient to find out the drug plants, as some of even I can see in my near my villages not a man can enter into a forest and search for the drug plants. It's a huge task, but a drone can perform, can make this problem a simple thing. See, the controller can control the drone, which has an autopilot. It can move throughout the forest or any farming areas. It can find the drug plants. It classify using image classification techniques. So it reduces the manpower, no need of manpower, and even this drone is made up of an IoT devices. It does not use any, doesn't need any high efficient of power and the devices. Motivation here we have is we need to provide a service to the government sector to stop these illegal activities. And using this autopilot drone, we can stop the growth of drug plants in overall India and make India as a drug-free country. So here are with the objectives in like once the drone has been moved to the targeted area, the drone has to identify the plants which are all near to it. So using the vision sensor, the drone captures the image. Vision sensor has a feature like it can capture in even in the night vision. It captures and modifies and pull the image to its own view. So after the capturing image, the image has been sent to the AI algorithm. That algorithm classifies the image which is a drug plant or else a regular plant. For as in this pandemic situation, it's quite difficult for us to show and demo. We have developed an interface that the controller explicitly adding the location and the details into that database. So this drone has a shortest path algorithm, so that after finding of the identified plants, the drone comes to its position using this shortest path algorithm. This reduces the time and power efficiency. And all these collected information which is stored in the database have been encrypted using cryptography techniques like engineer cipher and MD5 hashing algorithms. Only after the authentication, the controller can add. If any other authenticated person wants to retrieve the data, even he has to authenticate himself, and then he can retrieve the data. So coming to the existing system, in this pandemic situation, this drone technology is quite useful to finding out the person whether they are roaming even in the lockdown, are they roaming or else not. Police have been used with this technology. That's quite good. And in the proposed system, it's not even only for this pandemic situation. It can be used wide area. It is helpful for the overall country. And the modules involved like we have image classification techniques and the remote control GUI and the drone interface. This drone interface have been developed using the Tinkercad simulation tool. Just the drone frame has been developed. And the image classification techniques, like we have used the VGG16 algorithm for image classification, which is a convolution neural network model. It can classifies the plants and identify whether the target plant is a drug plant or else a normal plant. And the remote control application, we have included the authentication and adding the details of the location and the identified plants. So here is the overall architecture diagram. Is my diagram clear?
Arun, you put it in the slideshow mode.
Yeah, this is what the mission. Yes, ma'am. Yeah. Here, using the communication module, the data get transmitted from the drone to the database, and here the vision sensor, which helps to capturing the plant images. And once the captured image will be sent to the trained algorithm, so that algorithm classifies and identifies the drug plant. Here, even the drone has an autopilot that that saves it from the obstacles, and we have a battery and the power system. We have a GPS tracker so that the controller can track even the drone got missed. We can track, and there is an emergency alert. So somehow any unwanted issues have been going to happen, like someone wants to destroy the drone or some other going to happen. There is an emergency alert in the drone so that it uh, it it gives an intimation to the controller so that they can perform further actions. And this is the remote interface architecture. Once this interface will be held in the controller, there will be a screen in the controller. Once the authorized person wants to control the drone, he has to register and log in into this module. Once after the registration, he has to log in, and then after login, he's get verified with his details. So after getting into the home page, he has a features like he can access the features like adding location, list, and search. In adding location, he can add his authorizer ID and name and the location details. Here the ID and name can be visualized, but the location details are encrypted. Even while entering itself, the person cannot see what he have entered, so that it's for security purpose. And he has after entering the details, the person can search for the details or target details. These are the required hardware. You can see the visualize here the interface, remote interface, and the remote control. This is the drone we need, and mini tracker, and the workstation. This is what the simulation tool built for the drone interface. It's just a drone frame. After adding the vision sensor, we can embed this AI algorithm in this Arduino board. Let me show you the demo, how the image classification is going on, and then we'll go to the final conclusion thing. Yeah. Yeah, we need to import all the necessary packages and libraries. I have built this in the using Python. I have built the image classification algorithm. After getting all these libraries, we need to enter the data set. For an intimation, I have taken the plans of regular plans. I don't get any drug plans. I cannot prepare the data set for the drug plans. In this situation, I cannot go out and capture this. And even in the net, there is not a clear pictures of this to build a data set. So I have taken the regular plans and I have classified to identify the target plan. So once I get the data set, I can identify the drug plan. So I have entered the data set with I'm loading the data set. The data set contains these all plans, and here we need to put on a target plan so that for classifying. So I have taken the target plan as this plan, and after taking this plan, we need to visualize the target plan in an RGB mode to visualize to highlight the green colors and the red color in the picture. So here you can see the visualization of an RGB. Even I can say it is not clear. So to improve the visualization, I have used a HSV technique too. Once after visualizing the RGB, I have visualized HSV color space. So here you can see the highlighting the green color and the red values. After visualization, I am going to segment the plan, finding out the targeted, layering the plan, extracting the plan from the scenario. Here you can see from the picture, the plant has been identified. This is what from the picture I'm going to classify whether this plant is a drug plant or else not. And to get more accurate, I have just modified the color values. So here you can see the clarity in extracting the plant, as the drug plants have thin stem and thin leaves. So here, after minimizing the values, I just came to know that we can identify and classify little small plants too. And after performing the segmentation, visualizing the overall data set which I have entered, and this is what I'm going to classify the plant, whether identified plant is a drug plant or else a normal plant. And my teammate will show you how a remote control interface is going to work. Yamini, are you ready?
Yeah, I'll share.
Yamini? Yeah.
Yeah, I'll share. Good morning, everyone. Now I'll show you how this remote control interface will be seen. So this is the remote controller GUI, which is developed for storing the data. First, we need to register to log in into the application. I am giving the details here. It will all will be encrypted in in this format. So nobody else, if someone is there beside me, that person also cannot see what I am entering. For that security purpose, we have given the system here. After registering, it will ask to log into Access. Again, we have to give a password here. I'm giving my password here and submitting. Here we have three options. One is add, list, and search. Add is for adding the details, and list is for whatever the details we have added here that will be shown in the list box. If there is uh, a long list, we can search by a particular name in this search bar. So when I click on the add button, here the details should be given here. Authorizer ID, the name, the location information will be stored in such a format like how the password and username has been stored, so that no one can see the location and the further information. And we click on to add to database, it will add.
And with that he'll be facing a lot of issues. With this application he will be finding out correct urea and potash to use, and he can reduce the loss he's facing, and he can produce more, and he can sell it and be happy.
Okay, few questions here, Jawahar here. What are the sensors you are planning were using for this agricultural monitoring?
Sir, we'll be using sensors for like temperature, for finding out temperature, moisturing, and humidity, for humidity, and also weather checkup, sir.
Okay. And then you are monitoring it on the internet, right? It's on the ThingsWorks site or something like that.
Yes, sir. Yes, sir.
So how is this temperature, humidity, and others transfer to Things server? Have you written something? What is the
Sir,
data format you're using?
not only in things, sir, like we have implemented it clearly in Node, right, sir?
Okay.
Like the flow and all, but in general, we in like a hardware, we need a cloud software, and sir, for sending all that information to the farmer through SMS, sir.
Okay. Okay. So you will use the Arduino board to even send the SMS as well.
Sir.
Okay. So how much the overall cost will come in? Just to think. Your service, right? This would be more as a service, right? Because you would need some cloud service as well, right?
Yes, sir. like cloud in the sense we can use Google Cloud for working of this, sir.
Okay. Okay.
So it will be we can a student can use it like
Okay. Okay.
it less cost.
Okay. Fine. My questions are done. Thank you.
Thanks.
Pradeep, what will be a future scope of this project?
Ma'am, this we can like it can be used as an this app can be used for a lot of farmers, ma'am. Like uh, farmers need to get knowledge about this. Then it will be very useful for them to find out all that diseases for any crop is facing in his field. Find it out like easily, and he can cure that fast, ma'am. It will be very useful for farmer in the future.
It will be useful for the farmer. What will be future work on the proposed system? You are trying to improve some functionalities with the current system which you proposed. Do you like to
Yes,
improvise
ma'am.
some functionalities or anything you are going to deploy it? That's my question. Some features could be increased.
Yes, ma'am. Futures like we can updation of that futures will be coming, ma'am.
Okay, Pradeep.
And,
Thank you.
yes, ma'am.
The next team can take the lead.
Yes, ma'am. This is Chinmay, ma'am.
Welcome, Team Chinmay.
Ma'am, but we are in third.
Second one. Chinmay, you take the lead now. I'll check who is
Yes,
second.
ma'am. Second team is my team itself, ma'am.
Okay, okay.
Yes, ma'am. Ma'am, is my screen visible, ma'am? Yeah, Vaishnavi, you can continue.
My title, good morning everyone. My title is Social Distancing Indicator and Alarm System. The main aim we are doing this project is nowadays the social distancing is very crucial to preventing the spread diseases like COVID-19. So for minimizing this, so we are implementing this social distancing alarm system. And it is mainly for the blind people, ma'am. Actually, normal people have an eyes if they can see if any person is near coming to us. So that's but the blind people has no if any person come near to us. So that's why we are planning to do this detector for the blind people. If any person near come to us, this buzzer sign will run. So then easily can know the blind person if any person will come. And the existing system normally in worldwide there are so many visually impaired people are there. In that there are 39 million people are there, blind people are there. For the blind people there are so many devices there, but in this pandemic situation uh, in this pandemic situation, the social distancing is very important, right? So that in before that we don't need to social distancing, but the social distancing is very important nowadays. So that's why we are implementing this system. And in the proposed system, in my system, we are doing like gathering the information to the surrounding environment using sensors, cameras, and if any obstacle and if the user body comes to near us, then the buzzer sound will run. This we have a buzzer sound. It will and this architectural design we call an architectural design. Now will continue.
Good morning, everybody. This is the architecture diagram. First, there will be two people with certain distance. The ultrasonic sensor will detect the distance and it will give an alarm sound when two persons are coming so near. And the module for input module, as I said, there will be an ultrasonic sensor. It will detect the distance of the two persons. In the computational module, we have inserted some LED bulb. If the person is coming based on the distance, it will give the colors as red, yellow, and green. And the output module will get a buzzer sound when the person is coming too near. And in this is the implementation. We have done the implementation using Tinkercad. This is the first phase. And in this phase, if you see here, this is the object, means this is the person, and the other person will be here. So in this case, the person is outside. So here you can see the LED is glowing in green color because the person is too far away. And whereas here you can see the person is entering in near to the other person. So you can see here there are 3 green LEDs glowing. In the same way, here also you can see the person is entering still more near to the other person. So the yellow color LED is glowing. Here he came so near, so the full yellow color LED is glowing. Whereas in this condition, here the red color LED started glowing because he came too near to the other person. In this, the 3 LED red color will glow and it will give a buzzer sound that the person is coming so near to him. So he'll get a notification that the person is coming so near. We have implemented in Node-RED also by using. Now I'll show the implementation. As you can see, this is the Tinkercad implementation which we have done by using ultrasonic sensor. The person is too far away, reaching. You can see the 3 green LEDs has been glown. Color LED has started glowing. All yellow color LED glowed. Now the red color LED started glowing, indicating that a person is coming so near to you. Now you can hear the alarm sound because the person is too near to the other person. It will indicate with an alarm sound. Again, if we go back, the buzzer sound will stop and the distance will be increased. So the glowing of the LED will stop certainly. If you go far away, then it will completely stop. This is the implementation in Tinkercad. And then in Node-RED, we have implemented like text-to-speech conversion. This is our flow. And in this, we'll have a notification button. Here I have placed by using SVG graphics 2 persons. And then what is the notification? It will produce a notification by saying move towards left side because the other person is coming. And then if you click this person, in this Node-RED dashboard, it will show move towards left side. So a person is coming towards your left, so you should move towards this side. So until this we have done, sir. And our future scope is we'll get, when we click a person in this, we'll get a output in this node, debug node, that person is coming on which side and we should move to which side. And then future scope is we have to implement this also in this text-to-speech conversion, sir. And then it will be useful for blind people if they get some notification that whether the person is coming on which side, and based on that they can move forward because they can't see anything. And in this pandemic situation, this will be very helpful for all the blind people. So we implemented this, sir. That's it, ma'am. Thank you, ma'am.
For deploying it in the hardware, and am I audible? Jawahar, are you talking? Jawahar, your voice is not audible.
Yeah, yes. No, I'm not talking. I just wanted to.
Okay, you can ask the question.
Am I audible?
Yes, you're audible, Jawahar.
Okay. So you are using the sensor, right? Yeah. is ultrasonic sensor is the only input device we are locating here, because ultrasonic is more directional, right? It will not know around it. Isn't it the
Yes,
case?
sir. That's the drawback also we are facing, sir, because ultrasonic sensor will cover only one side distance, sir. If we place two or we should place four ultrasonic sensors, sir. Then it will detect in four sides directions, sir. And this can be done through hardware also, sir.
Okay.
But we have simulated in Tinkercad, sir, because we don't have that all.
Fine, because ultrasonic works in a directional way. It is more like a radar, right? It will hit and then it will come back to
Yes,
sense
sir.
it.
Yes, sir.
It will know that what is the distance. Uh, my view is you should look at some other sensors, because blind person maybe he is not aware which side he is looking at as well as that, right?
Yes, sir. We should look into it
Yeah.
also.
Okay. Yeah, that was my only thing. But otherwise, it is good. Thanks.
Thank you, sir.
Thank you, sir.
Chinmay,
Yes, ma'am.
to deploy it in the hardware, how much cost it requires for every.
Ma'am, actually, we did not think about hardware, ma'am, because as sir told, one ultrasonic sensor is not enough, ma'am, to build anything. We need four something which it took around. We should, for a person, it should analyze around the person, and it should know, ma'am, how many persons are there around him and in which direction he should move, ma'am. So we did it only in software, ma'am. We did not think about that in hardware, ma'am.
Okay, just research about it, how this could be deployed in a hardware. Okay.
Yeah, okay, ma'am. Or else we can do it in an app way also, ma'am, by getting some notifications for the person. Also, we thought in that way also, ma'am.
Okay. Okay, Chinmay. Thank you.
Thank you, ma'am.
Next team.
Ma'am,
Yes.
can I present now?
Yes.
Ma'am, can you see my screen?
Yes.
Yes, I see your screen now.
Yes.
Yeah, one minute. So our project is food energy. Our product. What is actually is we walk around 3 to 4,000 steps in a day, which equals 2.4 to 3.2 kilometers. So what we have done is we have made an IoT automation where we can generate this electricity with the help of our footsteps. This is how our system works. We are actually the main component which required for our project is a piezoelectric sensor, which converts our mechanical energy into electrical energy. And Arduino is used to show you how much amount of the voltage we have generated. One shield is used to display that amount of generated in our smartphone. These are the components required. Unfortunately, we don't have battery and one shield, but we have piezo and Arduino. We can show you now. Just a second. So can you see me?
Yes, we can see you.
Can you see my this pad?
Yeah.
So this is our Arduino here, Arduino Uno, and these are piezoelectric sensors which we are using here. we have 4 piezoelectric sensors in this box. You can see when I press here on this, there's this LED glows. And to show you how much of volt is generated, I'll just open my Arduino Uno. And you can hear serial number. You can see when I press here, this how much amount of the voltage is generated here. That's it, sir.
Okay, what is your application of this? How you want to use this as a product?
Currently, we don't know it, sir, but we thought of it in such a way that some people who like hiking, they'll go just they'll hike, they'll climb mountains, they'll go to some new places. The thing is, they don't have this energy to charge their gadgets.
Okay.
Some of the places where these guys don't have enough energy to charge their gadgets. So this is some kind of thing where we can have our own energy, which is produced with the help of our footsteps.
Okay. But you need to carry also the battery, right?
Yes, sir. But
sir, actually, we tried the battery, but we did not get battery hardware component, sir.
Okay.
Otherwise, the charge will be applicable to sensor, sir.
Okay. So, what is the max voltage you can get in with this?
we don't have capacitors to stabilize it. We are thinking it's below 5 volts because 3.8 volts is more than enough to charge our smartphones.
Okay. Okay. Thanks.
Have you completely deployed whatever you proposed in the abstract? Have you completely deployed it in the hardware or anything else?
If we had one field, we could have shown you the output in our smartphones, and we don't have battery, so that we can't able to charge the battery with the voltage generated.
Okay, you're planning to have some app?
Actually, we can use it in 2 ways, ma'am. With the help of Node MCU and Blink, we can able to show you this output in the phone, and if not, Arduino and with the one shield, we can able to show you in the phone. Actually, one shield uses one shield is a hardware component where it replaces all the extra hardware components which are going to connect with the Arduino. It uses our mobile phone to show you those outputs.
Okay, team. Good work. Bye bye. Thank you. Next
Thank
team.
you, ma'am.
Yes. Thank you, ma'am. Next team, who is going to present?
Yes, ma'am. Nandakishore and Bhanu Preetham, ma'am.
Okay, welcome.
Nandu? Is my screen visible, ma'am?
Yes, Kishore.
Yes, ma'am. Hello, ma'am. I'm Bhanu. Hello, sir. Our project is Smart Electrification Saver. We all know that nearly in these recent times, 400 to 500 death cases of fire due to electric shock. Our project is Smart Electrification Saver. Electrocution is nothing but it's a severe injury or a death by electric shock when the current passes through the body. Electrocution occurs it mainly due to the extreme climatic conditions or sometimes caused by the any man-made mistakes. We cannot completely stop the actions, but we can prevent the deaths. The main objective of the smart electrocution is to prevent the electrocution by alerting the people with the help of raising the alarm. This system works over internet through Wi-Fi. With the help of current sensor and bulb, we can check the current flow. When an abnormal flow detects, then an immediate notification will send to specific area, substation, and also to the lineman. Also, an alarm will rise at the particular transformer to notify and alert the surrounding people to don't go near the transformer. If you see the block diagram, you get the brief explanation about the project. Andrew, can you go to the block diagram? As we can see in this block diagram, from the source, the power supply will passes through the regulator. Here the regulator acts like a stabilizer which converts AC supply into DC supply because the Arduino works only on DC supply. Here the Arduino is programmed to read all the information obtained from the voltage and current sensors, so it will be able to identify the fault and abnormal conditions. It also sends the signal to GSM module to send the exact location of the fault. Later, the relay driver unit, as you can see this block diagram, takes the information from the Arduino and sends the proper signal to the relay. Here the relay which acts as a switch to on and off. So the relay disconnects the supply to the load during the fault condition and then connects it when the fault is cleared. Nandu?
Yes,
From now Nandu will explain.
as my friend briefly this about the project. So here we through this application we can not only save the lives, but we can also use this as like alerting system. So here we have used Tindercat for this implementation. So here we have the Arduino Uno board, and this is a PI sensor we have used, and this is the alarm, and this is the basic circuit we have used with the LED bulbs. As we know, in this pandemic we are not getting all the hardware and things. So with the efficient available things, we have built this. So when we start the simulation, actually we can see as we are in the Google Meet, you can't hear the alarm sound and all. So we have given a threshold energy. Like this is a potentiometer. We can control the electricity available. So after a threshold point, the bulb gets, the bulb gets blows off. So one second. This is a PIS sensor we have used. This sensor detects the people who are coming near. So after threshold energy, the alarm gets buzzed and the PIS sensor gets activated, and where we can alert people that you don't come near this point. There is some damage take place. So this is what we have done using the Tindercad, and future scope is to as of now we don't have any hardware, and our future scope is to implement this in the hardware so that it will be useful for the real system, and we can also implement using a biometric sensor a specific authenticated person can switch on it or switch off it instead of anyone doing it. So this is what we have now.
Yeah, Nandakishore. Just a question. When you are using a potentiometer to find the spike, right? How would
Yeah,
the
yes.
regulator would? How are you maintaining the threshold with Arduino?
So actually, this is a sample. So like we don't have the GSM model and all the other things are not available for free in this.
Okay, that's okay. It's not available in the simulator as well.
Yeah, yeah, yeah. So
Okay.
hello.
So just in the overall idea wise,
Yes.
if I want to understand,
Yes.
how would you know there is a spike or not? What is the actual component which you would be thinking to use in your project?
Actually, uh, in the Arduino itself, so like we can code uh, we can give a threshold after the some minimum current amperes, we can set that I think what.
Because Arduino would do only analog. Analog it can read, and or it can read a digital yes or no, right?
Yes.
So there should be some passive device which would need to tell it, right? What is the amount of current or anything is flowing through.
Sir, we have the multimeter right here. So
Okay.
here we can see the multimeter which shows which displays the
Okay.
current.
Okay. Okay. So you are reading the data from the analog multimeter in
Yes,
output.
yes, yes,
Okay.
yes.
Okay.
Thank you.
Yeah. Thanks.
Thank you, sir.
Kishore, what's your plan about its hardware implementation?
Yeah, we are we plan to implement in hardware, but right now we don't have any devices. If after this pandemic, we can do that in hardware.
So you have the scope or the future plan to deploy it in the hardware as well, right?
Yes, yes, ma'am.
Okay. Okay, Kishore. Thank you so much.
Thank you, ma'am.
Next team.
Ma'am? Yes, ma'am. We are ready with our presentation, ma'am. This is Aravindan.
Good, Arvind. Welcome.
Yes, ma'am. Good morning, everybody gathered here. So, our team is ready to show our presentation.
So, a very warm welcome. Today, our topic is data analytics using R. In this, we are analyzing consumer behavior about the spices they buy. So, our primary objective is to understand the important factors. Are in the next slide. So, our primary objective is to understand the important factors influencing the buying behavior of the consumers using our software. And our secondary objective is to know more about the consumer preferences and make suggestions for improving the sales of the spices. And the scope of the study is for focused on people visiting shops who buy branded spices and also who visit departmental stores and malls. And the sample size we took is restricted to 486 consumers. And moving on with the introduction to data analytics, it is just discovering useful information from the given data by inspecting data, transforming and modeling data, and drawing conclusions and support decision making. So it is broadly classified into three types. Descriptive analysis, which tells you about what happened in the past. Predictive analysis, which tell you what will likely happen in the future. And prescriptive analysis, which recommend actions for the possible outcomes in the future. Now, in this, we are doing descriptive analytics and diving into statistical analysis. So, statistics is data collection, data interpretation, data validation. Statistical data analysis is a process of performing these various statistical operations. And statistics is a quantitative research, and typically applies some form of statistical analysis. Quantitative data is involves descriptive data, and we have taken survey and observational data for our project. And usually, if the data size is very small, we can do manual calculations and conclude it. But if for our project we are taking like 486 consumers, in real life also data set will be large. So we have used statistical tool with the help of statistical tools like R software, and this R software cannot be performed by layman without having any statistical methods. And the data we collected is using Google Forms with a set of questionnaire about to analyze about the consumers, about their buying patterns and preferences. And statistical analysis, mostly we use percentage analysis and chi-square test in this. Now, a brief description about percentage analysis. Percentage analysis is the most common way of getting a result to drawing a result of a statistical data. It helps in making comparison between two or more series of data. So it just gives a fair idea about buying patterns of consumers. Moving on to chi-square test, this is an important test. Like it helps us to know about whether two attributes are dependent or independent. Here we are using test of independence of attributes. So in general, if p-value we will calculate for each attribute, and if we have taken level of significance as 5%. So if this p-value is less than 5%, we can conclude that those two attributes are associated. If not, they are independent. Now let's move to the final.
So good morning, sir. Now let's see what we have inferred from percentage analysis through a graphical interpretation. So for this graph to be plotted, we have used a library called SmartEDA and a command called xcatviz, that is expcatviz. And if you generally put xcatviz of that data set, you will get this individual graphs. So let's start with gender. So when we see that in gender, 54% of the females are frequent in buying the spices. Then 46% of the male are frequent in buying the spices. And it's obvious that females know more about spices than males. And when we go to the age category, there are 4 types of category: less than 25, greater than 46, 26 to 35, and 36 to 45. And if you see that 45% of the customers are in the age between 36 to 45, who are the regular buyers of the spices. And if you go to the next one, size of family, again it's been split into 4 categories. That is greater than 4, 2, 3, and 4. And in this, around 81% of the customers have 3 or more than 3 family members. So next we go to the price. So 65% of the customers consider price as an important factor, and 34% of the customers consider it as highly important. So almost 99% of the customers consider the price is an important factor. And if we go to the packaging, from the packaging we can see that 46% of the customer consider the packaging as highly important, and 54 consider the packaging as important. So almost all the customers consider packaging as important factor. And if we come to the taste, and from this onwards, it is factors of production such as taste, quality, freshness, etc. So first we start off with taste. 22% of the customer consider taste as highly important, and 66% consider taste as important. So almost 88% of the customer needs their product to be good, whereas this 12% consider it is neutral. It is neither important nor highly important. So this freshness and packaging are correlated to each other, sir. Like if the packaging is good, the product might be fresh, or if the packaging is not so good, the product will not be fresh. And in this, 49% of the customer want the product should be fresh, and it is considered as highly important, and 51 consider it as important. So almost all the customers consider it as important factor, the freshness. And this quality, taste, and price are correlated, sir. So how it means that if quality is good, the taste is also good, and if the taste is good, the price will be obviously high. So this quality of the customers, quality is given high importance by 71% of the customers, and 29% consider it as important important. So almost all the customers consider that quality is important. And this comes under brand awareness, sir. So brand awareness such as flex boards. If you need to know more about the product, you need some advertisement. So advertisement, we have just taken an example of that. So it's brand awareness can come under the flex boards or paper posters or etc. So almost 70% of the customers consider brand awareness is important. In that 19% consider it is more important because we need to know more about that product. And this is an example of brand awareness, that is advertisement. Many people will watch television all the time. So advertisement, if you need to know more about the product, you need a proper advertisement. So 70% of the customers consider advertisement as highly important and 30% consider it as important. And it's obvious that all the customers need advertisement as an important factor. And let's come to discounts or offers. So if you see discounts or offers, if the company put discounts or offers, you might buy the product even though it is cheap. So 88% customers consider the discounts and offers as an important factor. In that 34 consider highly important. And now comes the user recommendation. So this is an example that if your neighbor or your friend buys a product and if it's nice, they may recommend to you that this product is nice and you will be eager to buy that product. And this 55% consider it as important. In that 10% consider it as highly important. And the final is shopkeeper recommendation. So shopkeeper recommendation, some shopkeeper may not be loyal to you because of their shop's profit. They might sell a product which is high in price and low in quality. So 46% of the customer consider shopkeeper is unimportant, and remaining only consider it as 29% consider it as important, and 25% consider it as neutral.
Okay, now we are going to dig deeper into our data set. As we know that through the survey we have collected this data set, and all the data are mostly categorical in nature. So we are doing the chi-square test. It is one of the hypothesis testing. As you know, it is used to find the dependency between the two categorical parameters. So we have used our software. More specifically, we have used Smart EDA package for doing this chi-square test, but we can also use the inbuilt function called chi-square.test also. So when we go through our data, age is one of the factors. So we are comparing, we are finding the chi-square value, the p-value. As Shankar has already stated that we have chosen the p-value significance level as 5%. So if the calculated p-value is less than 0.05, then the two factors will be significantly associated. So from that we have found that age and brand awareness and age and shopkeeper recommendation have a significant relationship, significantly associated with each other. So for graphical interpretation, we have just shown the p-value that we have calculated, and this red line shows the significance level. So from here we can understand that brand awareness and shopkeeper recommendation is associated with the age. Next, if you go through gender, here we can see that gender is associated with quality. So if you want to understand, this is a best example for, if you want to understand the chi-square, this is a best example. If it is not associated, means we can say that the frequency of buying will be almost approximately equal to the ratio of people, that means the ratio of male and female in the population. But here we can see that quality, gender is associated with quality. Then we can understand that there may be some kind of relationship between these two things. Next, if we the same thing here, here we can clearly see that the p-value that is calculated between gender and quality is less than the significance value. Next, if you see here the family size and factors of production and promotion, here we can clearly state out that family size is associated with the taste, and again here it is represented by the graphical interpretation. Say then, if you see this one, like frequency of buying versus the factors of production and promotion, here we have surprisingly found out that frequency of buying is associated with user recommendation. So this thing we have to work on more these things to if you want to improve our sales or production. Now here again the same thing. Here we can see that the p-value calculated is less than the significance level. So these all graphs also we have used our software to plot using the normal bar plot command.
Then here we have did a special analysis of the product and quantity of buying with the frequency of buying. So here we can state out that the frequency of buying is associated with the quantity. Here we can work on these two, the stocks of these two, so it will be easy for us to increase our sales. So again here also we can see that the graphical interpretation for the same. So now my friend Sujit will continue with the final phase of our presentation.
So the last thing is suggestion. So before going to suggestion, I just want to make something clear, like to whom are we like giving these suggestions? So the one thing is like to already established brand which is selling spices, or a brand which is trying to start a field in spices so that they can sell spices. So these two are some of the companies which we can target and we can analyze and give the result to them. So like from whatever we have done, right, from the personal analysis and the chi-square test, we have come up with some of the conclusions which we can provide it to the company, and from that they can improve them. The first thing is like promotional offers can be like more and more like clearly explain to the customer so that as they consider it important, if you explain it in a very good way and a clear way so that if the customer understands it will be more better. And the second thing is like from the quality, what we have found is like 700% of the people consider quality to be very high. So if we keep a higher quality standard, we can reach the customer in a better way, and they will have good impression about the brand. And the third thing is like brand awareness and shopkeeper recommendation. So what we found is like shopkeeper recommendation is not that good, but what we can do is like we can ask the people, like ask the brand to improve on it so that people will have more affection towards the shopkeeper recommendation and brand awareness. And the third last thing is like advertising. So people consider advertising to be very important, so we can find a way on like ways through reaching it, for example to the online or offline. And the last thing is like try to segment your customer, because different age people and different gender people try to like think in a different way. So what we can do is like how can we target each one of these so that we'll cover the entire thing. So these are all some of the suggestions which we can give to them. And the last thing is like for future work. So till now what we have done is one is statistical analysis, but what we can further do in this is the predictive analysis and descriptive analysis. So statistical analysis just say about like what is the relation, but predictive analysis and prescriptive analysis say about what is the prediction which we can do and what can be done using it. So what we can do is like the customer behavior, like exactly how one attribute is related to other can be done using predictive analysis. Till now we found out like how to like whether two factors are associated in some way or not, but we have never said like in what way they are associated. So that can be done using predictive analysis with the help of machine learning algorithms. Like we can use clustering, random forest, and all those things so that we can classify and give out the final output. And then next thing is like we can also find how one attribute is different to other in a very better way. And one more thing is like we have taken data only from a certain particular region, but if you take it from a very vast region, so that the data will be more diverse and more generalized rather than more biased to one region. So using this we will be able to like know what is the exact relation and how people in each region like respond to it, so that we can target each region in that way. So like next references we are taking some, and if you have any question you can ask.
Yeah, thanks Arvind for this topic. So here data is very vital, right, to start with on the customer pattern.
Yes, sir.
And how is it collection going to be equally difficult, isn't it? What ways would you use to collect the data?
Sir, actually, most preferable way is through online, because most of them we are using all kind of social media. So through online, through Google. Actually, for this project we have collected through Google Form, but there is some of the disadvantages like people will be they won't spend much time on these kind of feedback forms. But when if we go directly to them through then huge malls, also we will be getting some improper kind of data. So it is vital, but we have to consider all these factors. But as much as we can, we have to collect it so that we can guess the exact trend in the market, sir.
Okay. So, would you use something to validate your results or your conclusions?
Yes, sir. Like if you want to validate our conclusions, then we have to go for creativity analysis. Then if you suggest to that like a small brand or a small startup which is going to enter into this kind of medium, then we can validate those things, sir.
Okay, okay. So you need a new product introduction to it, and then verify with the results once it is
Yes, sir.
launched to get it concluded.
Yes,
Also,
sir.
we can also do one thing, sir. Like previously, like we can take some other company's data and also validate with it. How is it performing in all these certain fields? So, like 2, 3 companies' data we can find and find how is their quality and how is this affecting with other factors. So
So
through that we can
again now will be shortage of data, sir. So we have to collect more and more data about it. Then we have to do the training set and testing sample. Then we can validate those things, sir. So
Okay.
so we must be going to the next step as predictive analysis.
Okay, okay, okay. Yeah. Thanks.
Thank you, sir.
Yes, thank you, Arvind team. Next team can take the platform now.
Yes, ma'am. My team is ready.
No, ma'am, next we have
Actually,
Vigneshwaran team.
Okay.
Yes, ma'am. Vignesh gonna present, ma'am.
Okay, Vigneshwaran.
can you able to see my screen now?
Yes, we could.
Yes.
Hello everyone. My project is Babla Ketchup. I'm Vigneshwaran and my teammate is Boglesh. The main goal of our project is to develop an affordable home security system for everyone. In recent days, the camera real systems and security systems are more costly from Godrej and from other companies. It costs more than 15K and 20K, etc. So I have developed a small system for home security. It consists of a node MCU and magnetic sensor switch. It's a node MCU. We are using Blink platform for our connection establishment. I can explain about it. We have to connect the magnetic sensors and to node MCU, and we have to load the Arduino code to MCU, and we have to connect the magnetic sensors to doors and the walls, and we have to connect the power system to node MCU, and when we open the door, we can receive the notification from the Blink application. If someone open the door. That's our project implementation. First of all, we have to connect the magnetic sensor to node MCU to wires. After that, we have to load the Arduino code. After successful loading of the code, we have to connect the circuit to power, and we have to mount the reach sensors. It's our project. It's our implementation. And it's working off our project. See, if someone open the door, someone open the door. Message will come out. It's a sample code, and I can show you the demo.
Ma'am, I will show you the demo. Okay, you will also show you.
We have to connect the magnetic sensors to the door mount. If you open the sensors, I will get the message that someone opened it.
You can see the notification. We are getting the message once the magnet gets
separated. We will get the notification. Our feature scope is we can connect the magnetic rate sensor through all openings of the phone. It is more affordable. The project cost of this system is 700 rupees, and the magnetic sensor costs 291. So we can afford more magnetic sensor through the entire doors or windows. We can connect that to wires, and we can use a single node MCU is enough for the connection establishment. And we can, if someone open any part from the house, we can able to receive notifications now. That's it. Thank you.
Why did you choose Node MCU in this case? Is there some specific reason here?
So the main motto is the real time. We have to establish Wi-Fi here, and it's a real time so that we can just choose
Also,
movies.
it's cost efficiency, sir. We can manage our cost efficiency with help of other nodes. It's too costly. We are just maintaining this project with
Comparatively,
this
it is
cost efficiency.
user friendly and cheaper. That's it.
Okay. Okay. So you need the Wi-Fi chip of Node MCU. That
Yes,
is
sir.
the
Yes, sir.
major requirement, right?
Yes, sir. The main drawback is the wires. We have to connect the read sensors through wires. That's the main drawback. But we can establish like normal things. That's it.
You said you wanted to manage multiple doors, right? When you have to manage multiple doors, would the Node MCU be able to scale up?
Yes, sir. Yes,
Yes,
sir.
we can do through wires. Yes, sir. So we are using wires, so it's easy for
With
next.
help of single node, we can implement, sir. But the complicated things, just the wiring, those things,
We
it
are
just
connecting entire sensors to and merging them to single node.
single
It's just
mode.
like a junction.
Okay.
That's it.
Okay. So this proximity sensor is it a digital one? Digital like it will give a high current or low current only if it is opened or closed, right? It's not analog device. It's a digital device.
Yeah.
Yes, sir.
Okay. Good, yeah. But cost-wise, I agree. It's less cheaper. Yeah, but I think when you are using a Blink server or something, which will just give a notification on your Android app or something.
Yes, sir.
It's real time. That's why we choose Blink for real time. Thank you, sir.
Yeah, thanks.
Thank you, team. What's your plan of this hardware deployment?
Ma'am, yeah, we can use more read sensors and we just complete the proper setup. We have to establish proper setup for this stuff. It is more not cost efficient. It is just like we have to spend 1,000 maximum for read sensors. We can establish a proper security, real-time security.
Okay, have you all identified the essential components required for deploying
Yes,
it?
ma'am. It's actually deployed by us, ma'am. We have all the outdoor component we have deployed by ourselves, ma'am. It's actually bought. It's actually bought through online, and we have implemented. We have connected, and we have implemented, ma'am.
Okay, team. Good. Goklesh and Vigneshwaran, thank you so much. The next
Thank
team,
you.
Hemant's team, you can take the lead since you have class. You can take it now. Hemant, are you here? Hemant? Hemant, are you here or shall I give the platform to the other member? So since there is no response from Hemant, the other next team can proceed now. Kindly take it.
Ashish, you may proceed.
Yes.
Okay. Good morning, one and all present here. Our project is for analysis of COVID-19 symptoms. Just is the screen visible? Yeah, thanks. So, we are just analyzing the COVID-19 symptoms with using our studio from the data we have collected through online. And the main motive would be explained by Akhilesh, my teammate.
Good morning, everyone. Our main motive of the project is COVID-19. The virus is spreading all over the world. Many people are aware of the symptoms, and most people are not aware of it. Due to the lack of awareness of the symptom, and due to late hospitalization, many deaths are causing. For analyzing COVID-19 symptoms, we have taken a data set from Kaggle, which consists of data of 5,000 people who had symptoms related to COVID or similar to that, and along with the results whether the person having a COVID-19 virus or not. We are taking the data of the person who have having the COVID-19 virus in them and analyzing their symptoms. What we are going to do is we are going to do statistical analysis with the symptoms and with what they have experienced, if they had fever or not. We have used by doing the research that we are going to prove that what researchers have been doing this using the statistical analysis, and also we are doing with the help of logistic regression we are doing predictive analysis. This will help in detecting the probability of the virus inside a person. And the next slide is the contains the summary of our data set, entire data set. Now Ashish will explain the next.
Sir, so since like we have got a big data set and we have to ensure that we have to predict actually the presence and absence of the illness. So we have gone through our studios libraries and all, and we have figured out library which is being used for ggplot. In ggplot we can have a bar graph. As you can see, this one is for the people who are experiencing the breathing illness, the breathing problem who are experiencing. This is the graph for them. So actually the data set how we have taken was, it contains if the person is suffering from any of the issues, so it will be counted as 1, and if the person is not facing the symptom, it will be counted as 0. So as you can see, this graph is varying from 0 to 1, which is the people who are not suffering or not experiencing the breathing problems, and this graph shows that the people are experiencing the breathing problems. And we have taken like the common common symptoms what people usually face. So this was the first problem that was told by the scientists, that when the COVID-19 attacks a person, it would be directly affected to the lungs. So we have taken the breathing problem, and we have taken the fever, and then we have taken for dry cough and sore throat and running nose. These are all the symptoms which we commonly face, and these are the symptoms which are commonly faced by the people who are suffering from COVID. And then we have taken for headache, which would be like this. This is a count, like 2,000 and more, the people who are suffering due to headache. And then this is for logistic regression, which would be explained by Akhilesh.
So for logistic regression, we are using CAT tools library for training and testing the data. We are using we are then splitting the data and training, and we are training and testing, allocating for more than 70%. It will be trained, and rest 30% it will be stored in testing data. Then we are finding out the logistic regression. Ashish, next slide. With all the symptoms, by taking 1 and 0 as yes or no, we are loading all the symptoms into the variable called new data. Then we are loading it into the logistic regression variable. Then we are predicting. It will display the overall probability. It will display 1 if it shows that the person with all these symptoms might have infected to COVID, along with the probability of its detection. This will be useful for to get the clear clarity when some person has suspect the symptoms as COVID. This can be developed either as a website or an app for further people's convenience. That's all, sir.
Okay. So why logical regression?
Sir, it has really 20 symptoms. 20 symptoms variables. So we have taken logistic regression, sir.
Okay. Because yeah, the logical regression is not the only way to determine it as well, right?
Yes, sir.
So what is the success rate for your test data? How much was your efficiency?
The final
Yeah, like it
prediction.
was being tallied, so like the data what we have collected and what we have got was it's really very impressive that it was being tallied like how many people were suffering due to the illness and how many were not. So that we could see in the graphs what we have derived.
Okay. So your text efficiency was above 90 or something, is it?
Yes,
Because of
sir.
Yes, sir.
okay,
It was nearly 95.
95%. Okay. So just a question: if someone says 95 is not good enough, and if someone says you need to have a better predictability, what you would start thinking to do in your project?
Yes, sir. Like as you said, it can be because this COVID is such a virus that we need like assurance or like at least of 99.9%. And so to increase, we have to like go for much more like instead of ggplot and logistic regression, we have to go deeper into the R studio and find out the way through which we can get it to the 99%.
Okay. I think. What was the sample size? You had 50,000 or something, is it?
No, more than 5,000, sir.
Or more than 5,000. Okay. 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 Fine. Yeah. Thanks.
Yes, sir.
Thank you, sir.
Yeah, Ashish, I have a question.
Yes, ma'am.
Yeah, is there any, by default, the level of significance you have given in that one, or to predicting about 95% significance?
No, ma'am. We haven't taken any, like, we haven't given any significance. We were just plotting it and then we were calculating how much rate we were, like, being successful of it. During the logistic regression, we've got the value like 0.975.
Okay, which test you are performing in this one?
No, ma'am, we haven't performed any test. We were like, we have derived the data. Actually, we have correlated the data. And then after correlating the data, we have taken the summary of it, and then we have taken a graph to relate to the COVID cases.
So the correlation is the right one to make sure that it will be 95% right result will be.
Yes, ma'am. Like since we have taken individual, like the illness was like specific to the breathing problem, and then again specific to the fever. So it was better way. It was a better way to like tally with the COVID cases.
Okay. Fine.
Thank you.
Thank you.
Thank you, team, for your presentation. The next team, Hemant's team, you can join now.
Ma'am, yes, ma'am. Ma'am, can you make Teju present?
Yes, you can share your screen.
Ma'am, can you see it, ma'am?
Yes, Teju.
Ma'am, actually our project is using the brain interface system home automation, ma'am. Actually, we are
Slideshow,
having
kindly put your screen in slideshow mode.
Yes, ma'am. Ma'am, yes, ma'am. Now can you see it, ma'am?
Yes.
Yes, we can see in presentation.
Sir, good morning, sir. So actually, our project is using the brain interface systems. We'll be doing the home automation, sir. Actually, we are having so many things already in the market, and through it now we are going to introduce some, I mean, like the apps are actually we are trying for implementing one app, sir. Okay, for the home automation. Like first we have tried for the LED bulbs. In that way we are going to implement all the things for any other things also. So let me show our idea, sir. So actually the goals of this project is, as we can see, today in our day-to-day life we can't able to, I mean, like we'll be so much stressed or something like that. So according to those things, you by understanding the human brains, the hardware will be like it will be supporting for the human life as usually. That's the goal of our project, sir. Actually now just we can see in this we are trying to implement with the Bluetooth option, sir. I mean, like Bluetooth or Wi-Fi module. As we can see in Tinkercad or something like that, we'll be having Wi-Fi module, right? So in that way, we are using this Bluetooth module to implement this thing. Actually, here we can see from the human brain, the signals will be taken through the Bluetooth module, and it is stored in the cloud storage. From the cloud storage, the I mean, like the things will be generated, and the hardware will work according to those cloud servers. Here we can see. Actually, in this we will be using Raspberry Pi, sir. The IoT platform which we used in this is the Raspberry Pi. Actually, it controls the smart devices in the home and executing those commands. We can know what is brain-computer interface, no? Actually, this is the concept which we have used, sir. In EEG means electroencephalography. We will be using for the getting the information from the brain waves. So this is the thing. There are two types of things: non-invasive and invasive brain-computer interfaces. By using both of these, we will be calculating the brain waves. At present, we are having so many things in the market. As we can see here, the first one is the biggest one, and after that, this one. In the same way, we are having so many things in this. We'll be using Noroskyve Mindwave Mobile. This is the thing which we are going to implement in the, I mean, like in the app session. We are trying to do it in the app session. It sends the data over Bluetooth energy, levels of mind attention, and the levels of mind relaxation. Actually, in this we have used as we can see, Kotlin. Kotlin is one of the platform for, actually we use this platform to implement the coding using the XML and the Java platform. Through this we are trying to implement the app session. So the app session is still not yet completed, but we are working on it. So sorry for this inconvenience, but maybe we will be implementing this thing by time being. Yes, sir. As we can see here, the one is the LED bulb, and the another one is jet stick. I mean, like through this module, we will be providing the signals to the hardware system. I mean, like the Linux and JavaScript, all those are the software things, and this jet stick is one of the intermediary message passing to the hardware system and the software. So can you hear me, sir?
Yeah, till now it was not, we couldn't hear you, but now yes, we can hear you. At least questioning that, can you hear us?
So till now you can't hear me, sir.
Not till now, just in a brief amount of time, maybe 30 seconds or something.
Oh, sorry, sir. Actually, I've been through all the
No,
topics.
no, no, no. I've been listening till your Z stick plays where you are talking about Z stick and it thing. The previous slide was where we couldn't hear you.
Okay, sir. Okay. Sorry for the inconvenience, sir. Actually, this was our project, sir. Now we are doing the app session, sir. We are trying to implement the app for this using something. I mean, like in this form, sir.
Oh, okay.
Sir, do you have any questions, sir?
Yes, multiple questions. You said you are using Raspberry Pi, right?
Yes, sir.
Why would you need to use the Raspberry Pi?
Sir, actually, for the message passing for the smart devices, we'll be using Raspberry Pi for one as the software intermediary system for the message passing, sir. Sir, did you get me?
So yeah, I got you. The question is for Raspberry Pi. What to which of the devices you would be sending these messages?
Sir, for the hardware device, like actually we are using the LED bulb, sir. I mean, like for the glowing of the LED bulb, we'll be using this, no? Through the Wi-Fi module, the message is being delivered to LED bulb that it has to be switched on or it has to be switched off or it has to, I mean, like, what you can say. I mean,
Okay, what is the protocol used between the LED bulb and the Raspberry Pi? Is it what is the protocol for between LED bulb and the Raspberry Pi?
I mean, like in the sense.
Okay, so your LED bulb should need to understand some of the topics, like can it be a ZigBee protocol or it's a LoRa RAM or something else. So what is your interface, that protocol interface between your Raspberry Pi and the LED bulb?
Actually, I can't.
Okay, no problem. It's fine. Yeah.
Yes, sir.
So you're more working on the BCI part to the Raspberry Pi now, is it? Or is it already?
Yes, sir.
Okay.
No, sir. Actually, we are working on it.
Okay.
I mean, like this is the what I have shown is just the. I mean, like the interface, how it will be, and what are the things we are going to implement. That's the main idea I have shown you.
Okay. So what is the cost of this project comes into? Did you anytime check? Because BCI is one of the very costly devices, right?
Yes, sir. Actually, for that point, I have some explanation. I mean, like one of the hardware company, I exactly don't know about that, but they're doing the project on this thing, sir. Actually, for the BCA things, it's very costly, right? As you said. So they're trying to get in the low amount, like only through the pins, sir. I mean, like they will be implementing some of the pins that will be just stick to the head or something like that through the race. Actually, I don't have the presentation for that. So if I had the presentation, I could explain you clearly. So
it's okay. Yeah. So the cost would that is the major part of your cost, right? BCI device.
Yes, sir.
Okay.
Actually, it's costly. Okay, I know, but we're trying to get it some less amount or in that way. In that way, we are trying it, sir.
Okay, okay, yeah. This is one of the like it's too new to be have a cost effective as on today,
Yes,
and
sir.
it's
Yes,
like
sir.
that. Yeah. Thanks.
It, it's okay. It's okay. It's okay, sir.
Thank you so much,
Yes,
Hemant
ma'am.
and Tej Prasad.
Yes, ma'am.
Next
Thank
team,
you.
you can take the lead.
Okay, thank you, ma'am.
Yeah, ma'am, this is MC8034.
Fine.
This is me, Suhail. Good morning, everyone. Good morning, sir. Let me share my screen. Just wait a second. Yeah, so I hope my screen is visible.
Yes.
So today we are going to talk about it's a simple but useful project. It's the key to winning a game of Monopoly most of the time. So it's a step back from your far-fetched like big project ideas, but I hope you're all familiar with the game of Monopoly. It's a fun game to play with your family or friends. So what we've done is we've taken the seemingly random game, right? It's random. A pair of dice is always random. How can you predict where a player will go, or how can you predict which squares will be landed on the most? We've taken this project and we've done a statistical analysis on it using several concepts, and we've run a simulation. So what a program does is it simulates a game of Monopoly over and over and over and over again, something like 10 million times. The computer plays Monopoly against itself, and it gives us the result. So we can see it in an interpretable data format as to which is the best way to win the game of Monopoly. So for those of you that are unfamiliar, what is Monopoly or how does it work? Basically, it's a game where you buy and sell properties, and the goal of the game is for a player to win. They should basically bankrupt the other players. So there are four players. One player should bankrupt the other three players such that he is the only person left with money in their balance. So that's the aim of the game. So yeah, as you can see, the last player remaining on the board is the winner. Here's the map. So there's a total of 40 squares and 8 color groups: brown, cyan, pink. So we've taken this and programmed it such that we can predict or track where on this board, which position do players land the most, which squares are more likely to yield a profit on investment. All that concepts we use, and basically we're just giving you a simple answer. How do you win this game? So now these concepts that I told you about will be further explained by my friend Melvin. Melvin, would you take over?
Yes, hello, I am Melvin. So the concepts used are statistical analysis, model simulation, graphical representation of data, and now I'll be giving a brief description of the idea behind the project. So we use the concept of dice mechanism. So what is dice mechanism? So I have a question for you all. If you roll a pair of dice, just think about the number which is most likely to appear. Is it 4? Is it 8? Is it 2? Just think about it for a minute. Yeah, it's actually 7. Why 7? Using probability, it is found that the number of combinations that add up to 7 is more than the other numbers. So the graph that you are seeing here was got after simulating a pair of dice which was rolled for 10 million times. So after we so 7 was the number which we got after which we got after rolling the dice for the most of the times. So we also took other factors into consideration, such as Jade and the community chest. We factored all this into writing our program. And yeah, now my friend now my friend Suhail will be explaining about the code.
Yeah, so this is basically the code we've written. I would ask Share to explain maybe at least the first half, and I can explain the second half. Share, do you mind?
Yes, thank you. Hi, good morning. I'm Shra. I'll be explaining the first half of the code. So we have imported pandas to read the data file, and matplot libgut.pyplot is used for plotting the graphs, and seaborn is used for advanced graphical representation and heat maps, and numpy is used for dealing with random numbers, and random is used to generate random values. And so this function is used to roll a set of roll a pair of unbiased dice, and this function is used to plot the graph, and this function is used to find the probability of landing in a certain space, and this function is used to create a pack of empty cards, and this function is used to pick a card, and this function is used to shuffle the cards, and this function is used for assigning the positions for each place, and this function is used for assigning the pack chance and community chest. This function is used for checking the card action, and then this function is used to pick card chance or and community chest, and this function is used to move the players, and this function is to start the program, to roll the dice, and
Yeah, so
Suhail will
that's
take
the
up
first
the.
of the function. Yeah, thank you.
Yes, thank you.
So basically, this part of the code you can assign the number of rows you want the program to do. So say if I put a million rows or 10 million rows, it'll roll the dice those many number of times and track the player movements across. You're putting in all the factors, like every single variable of the game of Monopoly is factored into this program, whether it's going to jail or going to certain parts or drawing random cards which give random actions. We factored all of that in. And so approximately when you do rolls over a course of a huge number like a million or 10 million, they basically average out and you get true data or near true data as to what exactly is most likely to happen over a course of a game of Monopoly. So we've created dictionary mapping all the positions with the names of places, and here this is the code for we use the Seaborn module to create a heat map, as you can see here. We'll further expand on this in a later section. So that's pretty much the code. This is all graphical related code. So we've done all this, and my friend Tushar will tell you what is the final conclusion or what observations do you take away from this, and how do you put it to use the next time you play a game of Monopoly? How do you crush all your family and friends when you're playing with them? Yeah, Tushar.
Okay, thank you, Suhail. So yeah, hi, I'm Tushar Mahatma. So now, according to our observations, based on our statistical analysis, you can see that jail is the most visited place compared to all the other places in the map of Monopoly. Why? Because there are many ways in which you can reach a jail. It can be due to the roll of the dice, and there is a place where you can get a chance on a community chest. It is a part of the map. In that, you'll be able to see that they'll be written as you have to go to the jail and so on. If you can observe the chance, if you can see the community chest, based on the number rolled on the dice, there are chances that it will be given that you have to go to jail. So there is a high possible chance. Followed by jail is the Illinois Avenue Point. That is the second most visited place. Then comes the starting point, which is the place from where we start the game. Now, can you just move on to the next slide? Yeah. Now see the heat map. You can see that the jail has 5.513% probability. Whereas if you see the followed by Illinois point, which is 2.993, then comes starting point, which is 2.929. Now, when in each for each place there is a color given for that. And I'd like to say that orange is the most perfect color group you to select. You know why? This is the place where you will get. It is very expensive these areas, and the rent which you're collecting will be more. This will give you an advantage to earn more money, hence helping you win the competition, making the competition easy and helping you move forward and win first place. That's what I'd like to say. Thank you.
Yeah, so basically the takeaway is do everything you can to get the orange color group because jail being the most visited place, orange is the color group that immediately follows jail and it's about seven to eight dice rolls away. So we know that 7 is the most probable number to be rolled on a dice. So whenever a person goes to jail and they get out of jail, they're going to land on orange most of the time. And so getting a color set of orange and building a few houses on them is almost guaranteed to win you the game most of the time. Which is why in a lots of pro Monopoly competitions, orange is the most coveted and sought after color group, followed by red, of course, which is a close second. At least getting one of these color groups puts you in a high chance to win. Getting both almost instantly guarantees you the win, and there's nothing else the other players can try to do when it comes to contesting the rates of rent and return on investment of orange and red. So that's basically our final conclusion after all of the simulation and analysis. Thank you. Do you have any questions? Anyone? Or sir, do you have a question?
Yeah, nice analysis on a game of Monopoly. Question is, you are does this changes when the number of dice rolls are lesser, and then when you do it?
It changes. Sir. Yeah, the question is about averages, right? When there's a lot of room for variation when the dice rolls are less.
Okay,
so yeah.
You have used a sample of 10,000 or 1 lakh or something.
10 million, yeah.
10 million. Okay, 10 million. Okay, that's huge amount of.
Yeah. So to minimize the variation and error, we take a large sample size.
So, can your analysis be used in other games as well? If I'm thinking it as a model, not just for Monopoly, can we use this algorithm or logic to other games as well?
Yeah, for sure, definitely, sir. You just have to vary the number of positions on the board. So it can be used for any different game that uses the same concept, which is a pair of dice being rolled. Because if it's one dice, then it's truly random. You can't do anything. But when it's a pair of dice, there are more combinations that add up to 7. So 6, 1, 5, 2, 3, 4. So any game that follows to a set of a pair of dice and certain positions on the board can be applied using this algorithm, and you can get the best way to win at any game.
Okay. So, why Monopoly? A simple question. Maybe you can.
Yeah, Monopoly because I don't know. I play a lot of Monopoly ever since I grew up, and it's very competitive, very cutthroat. Especially when I played with my family, and one of them gets bankrupt. The look on their face is like it's beautiful. So it's a very cutthroat game, and I used to lose a lot when I was younger because I'm the youngest in my family, and they're older than me, so they used to play better than me, and so that kind of played into a factor when we were choosing which game to simulate. I was like, alright, I'll get good at Monopoly, I'll beat everyone. That kind of. It was just a simple thing. Yeah.
Okay. Yeah. Thanks.
Okay, thank you, sir. Thank you, everyone. That's our project.
Have you applied this algorithm in your real life? Have you won the match or the game?
Yeah. I've played ever since we've done this and we've got orange and red. I've played online. I've played with my family. It works most of the time. Like undoubtedly, if you get orange and red, I've not lost a game so far. But once you let other people know, they'll also come to know, like, okay, he's going after orange every time, so we'll not let him get orange. So it's a back and forth with that, but it's fun.
Good.
I do have a question. If more than one people knows your statistics, then how it could be addressed or handled?
If multiple people know, then it comes down to pure chance. The one who gets orange wins. So that's the point, right? So you go to, like, you know the static, and then you play it with people that don't know, and you win, and then they'll come to know, and then they'll play it with people that don't know, and so it just word spreads around. People have a good time.
So if multiple people knows the statistics, then the probability of winning the event will get reduced, right?
Yeah, we'll get ready because other people are going after it as well.
Okay, so this may not be a universal application, right?
Universal application as in to other games, or this game but with other people.
It's I feel that it might be like gambling, right?
No, not because it's a statistics game, right? It's not exactly gambling, but if all the people, like if 4 people are playing and all the 4 know, which is highly unlikely, then it becomes a game of chance. Yeah, then I agree.
Okay, fine. Good try, team. Thank you so much.
Thank you, ma'am. Thank you for your questions. Thank you, sir.
Thank you.
That's our project for today. Thank you.
Thank you. So the next team, other statistics team is available, right, Mokuna ma'am?
I think Nitin is there, but he's doing on IoT.
Okay.
So should we present or should we wait for a statistics team, ma'am?
You proceed, Nitin.
Yeah, okay, sure.
No more statistics team hereafter.
Okay. Can you see the screen, ma'am?
Yes.
Yeah. Okay.
Good morning, everybody. I'm Aditya Athaya. My teammates Nitin, Tejeshwar, and I. Today, I'm going to present our idea for a smart irrigation system as our submission on the topic of Internet of Things. Just take it on. Tejeshwar, can you move to the next slide? Great. So, smart irrigation system is our attempt to automate the irrigation of fields and to do so in the most optimal manner. So, what we're trying to do is elevate a normal irrigation toolset with sensors, actuators. Here are actuators and water pump and microcontrollers, which will allow us to measure the chosen stimulus, process that information, and adjust the watering of the field to optimal levels. So now I mentioned that we have a stimulus. Actually, at the beginning of the project, we had a choice between 2 stimuli. So the first one was real-time weather. Now real-time weather is dynamic; it's unpredictable. So we would need a mini weather station on site, which would be able to measure the humidity, temperature, the rainfall, and the solar radiation received by the crop at that point of time. All of these factors together would go into predicting how much water the soil would require or the plants would require. The other stimulus that we could have chosen is the soil moisture content. Now, the moisture content in the soil actually lets us know how much water is already permeated into the soil and how much more it would require. So, we've actually gone ahead and chosen the soil moisture content in the soil for as our stimulus for this smart irrigation system. The reasons for doing so are actually that if you consider weather as a stimulus, there are multiple factors and parameters that we have to consider. All of them above the ground, which would actually make it slightly less accurate as to how much water is present in the soil. So we found this the second method to be much more direct. Also, not to mention, it's much more cost effective and cheaper to implement a moisture-based system instead of a weather-based system. Now I'd like Tejeshwar to take over.
Okay, so these are the components which we'll be using in a project. So we're using a Node MCU board here because it comes with integrated Wi-Fi connectivity because of the ESP8266 module. And we're using the soil sensor. It's the main sensor which of this project. So this is used to measure the moisture content in the soil. And the DHT11 temperature and humidity sensor measures the temperature and humidity. So we're using this is actually an extra part of this project. We're using this to just get an idea about the external weather, like about the temperature and humidity and the weather in the farm. And the mini water pump is to pump out the water based on the readings obtained from the soil moisture sensor. And the relay module is actually to power up the water pump. Nitin will be actually explaining about the significance of the relay module in the working section. And jumper wires are the connections. And the last part is the ThinkSpeak cloud platform. So the data obtained from this entire system about the moisture content and the water content, the temperature and humidity, it's actually sent to this cloud platform. And this is a MATLAB-based cloud platform. So we can actually perform analysis on this data, plots, graphs, and we can actually visualize this data. So in case if we make any future advancements on this design, so we can compare between the past design and the current design and measure which is more efficient. So that's one advantage of using this platform. So moving on to the next slide. Yeah, so as I mentioned before, there are two main sensors used here. One is the DHT11 sensor and the soil moisture sensor. So the DHT11 sensor is pre-calibrated. The soil moisture sensor is actually calibrated by the manufacturer according to the conditions which are present at that area. Like usually the procedure is they calculate the this value, the specific value which is known as the VWC, volumetric water constant, which is the ratio of liquid water to volume of soil. So this is done by taking various types of soils and they calculate the VWC, that is the moisture content basically for all the soils, and they take the average and they calibrate the soil moisture sensor to that particular value. But then the user might have a different type of soil, entirely different type of soil on his farm, right? So he's not going to have an average value of all the types of soils. So to suit the conditions at this particular farm, we need to calibrate the soil moisture accordingly. So this is done by the working of the soil sensor is actually, it has two plates, and the soil will be the dielectric material which is going to be fitted between these plates. So we measure the voltage between the two plates and calculate the dielectric constant of the capacitor. So this dielectric constant is inversely proportional to the moisture content of the soil. So by doing so, we can calibrate the sensor accordingly to the moisture content of that particular farm. So that will be the calibrating process. And in the following slide, Nitin will be explaining about the circuit diagram and the working of the system. Nitin?
Yeah. Can you see the slide? Okay. Yeah. Fine. So right at the center of our project is the node MCU. This is going to be the brains of our project. All the computations and other stuff is going to be performed in the node MCU. And as Tejeshwar and Aditya have already mentioned, we have two sensors in our project, the DHT11, which you can see on the top left, and the soil moisture sensor in the bottom right. This actually has two separate circuits. This one on the top, the bottom left, the pump, the 9-volt battery and the relay, that is actually a high current circuit, and the node MCU circuit with the DHT11 and the soil moisture sensor is a low current circuit. The node MCU actually can give only up to 100 or 10 milliampere maximum current. But the pump that we are going to be using is actually going to need a little bit more current. It requires at least 1 ampere current to function. So for that, we have an external battery, an external power source to give it the additional stimulus for the pump to work. And now, in order to explain how this works, the DHT11 sensor basically uses two electrodes. And between these two electrodes, there is a moisture absorbing substrate. And this substrate varies as per the humidity changes. Right? And based on that, the temperature and the humidity is measured in that sensor. And as Tejeshwar had already mentioned the working of the soil moisture sensor, this is basically just to calculate the dielectric permittivity of the soil and using that to find out the water level. And now, the temperature, humidity and the soil moisture is being continuously monitored by the node MCU. And when the moisture level goes down to 50%, that is half of the optimum value, then this node will send the signal to this relay, which then activates the pump. And then the circuit on the top and in the bottom left is complete. So the pump works for a brief amount of time. For our project, we have chosen that time to be 3 seconds. So when the water level or the soil moisture level goes below 50% of the optimum value, the pump is activated for 3 seconds. Now, if the moisture level hasn't gone more than 50%, it will get activated again. If it has gone above 50%, then it stops. The signal to the relay stops then. Okay. As I have already explained, this is the flow diagram. The soil moisture sensor sends the moisture levels to the node MCU continuously, and so does the DHT level sensor. If it is less than 50%, the relay is activated. The relay in turn activates the water pump. One thing that I had not spoken about earlier is that the mode of operation in which we will be using the relay. The relay module that we are going to be using here is going to be used in a normally closed mode of operation, which means that the relay, when it is in the closed circuit, when we give it a high signal, then the pump shall not work. When we give it a low signal, that means we do not give any signal, that is when this relay gets triggered. That is the meaning of this normally closed mode of operation. Right? So, except for those 3 seconds where we want the water pump to work, the signal will be on. And when we want the water pump to start working, we give it a low signal. That is what triggers the relay module, and the power, the current that the pump needs is actually obtained from the external power source, the 9-volt battery that you saw over here. Fine. And one more thing that I forgot to mention is that all these values are continuously saved and sent to the ThinkSpeak cloud environment, and the system performance can be monitored as Tejeshwar has already mentioned. Now I'd like to hand over control back to Tejeshwar to mention about our finance aspect.
Okay, so this is the basic idea about the budget of our project. So as mentioned above in the previous slides, these are the main components that we'll be using. So the average manufacturing cost of our product sums up to 800 rupees. So the cost is subject to variations based on the future conditions. That will be our budget actually. So that was a brief description, and moving on, the final slide will be presented by our
So as I've shown you already, the project that we proposed, we think covers almost all the essentials that we want to achieve. But we hope to optimize deployment based on what is being irrigated. Also, another improvement that we've already thought about is how the system interacts with the user in terms of, say, information relay regarding when the water pump was used or how much water was used in the irrigation during a certain time periods. Also, more general information like hardware faults could also be communicated to the user. That's it for our project. We'd be happy to answer any questions you may have.
Okay, I have two set of questions. One, you mentioned that in your relays, right? You're using a normally closed loop.
Mode of operation.
Yeah. Why did you have to choose normally closed? What is the significance of having normally closed?
Generally, like the normally closed mode of operation is being used for fail-safe systems. Like, let's say you have some poisonous gas and it's venting or something, you want to stop it immediately, you use the normally closed method. Since water is a fluid, I thought, okay, maybe we can use the same method. Normally open is also equally viable in this case because the volume of water we're going to be using is not going to be too much.
Okay. So another one question is because you are using a 3-volt pump or a 9-volt pump here, that's mostly for a demo. So in case of real scenarios, you might have a 3-phase pump, most probably in agriculture scenario. So what changes you would need to bring in to your agriculture system here? Have you thought about it or anything?
I guess the main change that we would need to bring in is external power source. I mean, we most definitely can't operate a 3-phase pump with a 9-volt battery. That was just for the presentation purposes. We might need to use a 220-volt AC plug for power, or maybe even a generator, depending on users.
No, that's okay for the power. Do you need to change in your product, like your relay need to change or something? You need to bring in additional logic to cover high power motor?
I guess the relay would suffice if we are using an AC outlet, I mean like a normal AC outlet. But if we are using something even more high powered or something that supplies power at even a higher voltage, then maybe we need to think about a change in relay.
Okay, yeah. Think about it for your future improvements, because to make it real life, you need to think of high power devices.
Yeah.
Sure, sir.
Sure. Yeah.
Any more questions, ma'am? Or sir?
Thank you. No questions for that. Yeah.
Yeah. Okay.
Thank you.
Thank you, sir.
Okay, thank you, team. The next team is Pahel team, or anyone is going to present now.
Yes, ma'am. Can we present?
Yes, Pahel.
Okay, ma'am. Ma'am, can you see?
Yes, we can see.
Hello, everyone. Our topic is healthcare companion. Healthcare Companion is a software which scans our whole body and analyzes it for injuries. It also analyzes heart rate and respiratory abnormalities. It does this by different sensors, for example, ultrasonic sensors, IR sensors, and optical sensors for 3D imaging. What we do is that we are putting all these medical procedures in the cloud, and when the sensors check the body, it will go through all the procedures and check it and give the information accordingly. The information will be stored in the cloud so that it can be connected to a single loop, and here's where the IoT comes. We are planning to use IR UWB sensor to check heart rate and respiratory patterns without any physical contact. We have an existing system with contact, but what we are doing for Healthcare Companion, it's without contact. So here's a comparison between the existing system with contact as well as our system that we are making without contact.
So hello ma'am. So first of all, the existing system, it's already with contact. So like as you know, whenever we go for any labs or for any checkups, normally they use sensors on our body to check like different levels of stuff. Like for example, they use ECG to check our heart rate. So what we are proposing is that we don't need contact. We change most of them into non-contact so that even in such a time, like body checkups will be more easier to conduct. And also, if you want, you can do this in your home itself for your own personal uses. So now this is a block diagram for the existing system, and that as you can see, like everything is connected to the Raspberry Pi module. and heartbeat sensor, blood pressure sensor, temperature sensor, everything is connected, and you connect these sensors into our body to check how it is working. And for our proposed system, as you can see, what we are planning is to connect all these sensors into an Arduino or Raspberry Pi, and then store all the data in a cloud, like different medical procedures for like each category. For example, heart, lungs, then for respiration, lungs, then kidney, different ways. And then we have like managed to consider all of these into some few sensors as of now, so that we don't need a lot of sensors to check each item. For example, we are using IR sensors for like there's a particular IR sensor from which we can check the temperature of our body using non-contact. Same way, we can use ultrasonic sensors to check if there is any abnormality inside, for example, tissue damages, bone damages, and etc. And also, we can use optical sensors to check if there is any damage on the outer body, and we can use that also for 3D imaging, so that to see if the heart is beating properly, or if there is any abnormality or any extra tissue buildup inside our bodies. So for that, what we are doing is that we are using ultra wideband or UWB on each of the sensors, so that its accuracy and power increases, which will give us a more concentrated view of the things in the human body. But as of now, as we are not able to get the hardwares or any proper simulation tools, because for simulating a whole human body, we searched a lot and we didn't get any proper simulation tools. So what we did is that with available sensors, we made a few simulations in Tinkercad for each of the sensors, so that what we actually have to do is combine all of these sensors into a proper one single unit.
So this is the simulation of the ultrasonic sensor that we have done in Tinkercad. We have also done like TMP temperature sensor, as well as the IR temperature sensor with LCD display. This is the graph of the temperature sensor. And I'll show you the simulation in the Tinkercad. So this is what we have done for the ultrasonic sensor. We start simulation. Here's the code that we have written, and here is like the distance for the serial monitor. We can, as you can see, the LED is not glowing here because of what the parameters we have said. Like if the LED pin is, if centimeter is less than 100, it will be high. So as it's 136 centimeter, it won't glow. So if we just stop the simulation and change the parameters over here, it should glow. And when we start, the LED starts to glow. So this is the ultrasonic sensor that we have done. We have temperature sensor too, made from both IR temperature sensor as well as TMP temperature sensor. We thought of doing temperature sensor without contact, but that component is not available in Tinkercad. So we made just this one. This is the temperature readings, and this is the graph that we are getting. If we change the temperature accordingly, the graph will increase or decrease accordingly. So this is what we got for the temperature sensor. And as it's a vast project, so we have just done like 2 or 3 different sensors, but we were trying to make like 4 or 5 different sensors combined to make a whole scanning system, which will give us different information, and that we use it using Wi-Fi module communication to get a whole details of the scanning results, and we will store it in the cloud. Thank you.
So, ma'am, is there any doubts?
Yeah, in your architecture, you are talking about Raspberry Pi, right? And your simulation is mostly on Arduino, is it?
Yes, the Raspberry Pi is for the existing system, so we are trying to do our new system on Arduino.
Oh, okay. Oh, okay. I thought I missed that point. I was thinking it's on a Raspberry Pi only. So.
No, so the existing system is on Raspberry Pi.
Okay. Okay. And to integrate all this into a single Arduino means you will use all the ports, is it, separately for all 3 different?
So we were thinking that we actually need more than an Arduino to integrate all this together, and also for like checking the bonds and everything using ultrasonic. We have to like actually implement it using the 3D imaging. So for that we will also need like graphic ports and everything. So like we need more of a motherboard actually rather than an Arduino. But as for now, we don't have like enough hardware for that. We actually have found out like which all sensors are more like useful for this. So like with that, we just made a simulation with whatever is available right now. And also as it's for human body, like the simulations are not available that easily to compare.
Okay, yeah, good try. But I think this you need to work a little more with this because it's on a healthcare, right? Most of your the sensors, you need to check what is the limit or whether it is even useful for getting the data.
So we already like checked some of the already existing items with non-contact. For example, right now most of the stores are using non-contact temperature sensors to scan our temperatures when we go into the stores.
Okay.
So all these are under non-contact itself. So if we use them and use ultra-wideband to increase the range and accuracy, we can get it into a 1 meter radius so that the person only have to stand in front of the scanning system and it will scan.
Okay.
If we give the proper code.
Okay. Okay. Yeah. Thanks.
Thank you, sir.
Thank you, sir.
Yes, what is the scope of your deployment? Hi.
Yes, ma'am.
As I told you in the beginning, this is a vast and a much complicated one. So
Yes,
you have to be very specific in finding and analyzing things, right? So
Yes, ma'am.
what is your future plan on this?
Ma'am, as like there's a hardware component which is used for measuring temperature, which is a non-contact one, because the one we have used is a contact one. So we were planning to use it and make the hardware thing, but the component wasn't available. So we are just trying to figure out the substitutes for all these contact things with the non-contact ones. And once we get all those things, we can try to make and combine them in a one system.
Okay, fine. Proceed. Thank you.
Thank you, ma'am.
The next team.
Yes, ma'am, we are ready. Ma'am, is my screen visible?
Hello.
Hello.
Yes, it's visible.
Okay, thank you. Good afternoon, everyone. Our project title is COVID-19 Protection Gap. Coming to the abstract. Our main aim is to develop two models, one which ensures social distancing by human detection and another one will prevents us from touching our face, and we need to combine both and place it on a cap so that it will be as COVID-19 protection cap. These are block diagram. An existing system with respect to COVID-19 protection is a device which is using for temperature without using any body contact sensor. In this, we have shown the procedure, how it will be done, and label the work happens in the module. Coming to implementation module, circuit design will be done here and use the respective sensors for our needs. We have used the ultrasonic sensors, and for human detection, we have used the PIR sensors. And in the output module, we have used a LCD screen in which we can show the output as if you are in a secure region, it will show as you are in a safe region, and if you are not in a secure region, it will show as you are not in a safe region. Materials required for this product are Arduino Uno, ultrasonic sensor, PIR sensor, potentiometer, buzzer, piezo sensor, LED sensor, LCD screen, and lights. This is touch prevention simulation circuit, and this is social distancing circuit. Now Saiti will show the simulation for this. Saiti?
Yeah, I'm present. You stopped presenting.
Yeah, I did.
Is my screen visible, ma'am? Hello?
Yes, it is visible.
Combined circuit. I start simulation.
Our main intention is to combine both devices, ma'am. One is for social distancing and one is for touch prevention. Here, ultrasonic sensor reads detects about the touch prevention, and the PIR sensor detects the human. On the LCD screen, you can see the output.
We can see.
After scanning through the PIR sensor and ultrasonic sensor, it will show the output in the LCD screen as in a safe region.
We have done our UI in the Node-RED, ma'am. These are Node-RED UI.
You are thinking to design applications
login and registration. And even save it in the local database using all the details of login and registration. Human detection, he or she can check their status whether they are safe or not. And the sound is audible, ma'am, but in Gmeet it is not audible to the ma'am. And the record how many times they their hand to the face, and their important points not to touch face will be displayed if it is developed in any application. Node-RED implementation.
Yes, so basically this is our user interface, and that is our hardware components. Yes, ma'am, we are done, ma'am.
So you said you are finding out how many times someone is touching the face, right? Which of the sensor is used for that?
For touching prevention, we are using ultrasound sensors, but we are not sure about the number of times. But we need to implement the code accordingly, sir, actually. But we are combining both, sir. But we need to make sure about the codes.
Okay. Okay. See, ultrasonic is mostly used for finding distance, right?
No, sir, it also used for detection also, sir. We have seen the reference purge also, sir.
Okay.
See reference purge.
And PIR?
For human detection based on their heat.
Okay. 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 And what is the level of means till how far it can detect the human detection? What is the?
So actually, PR sensor can range up to 10 meters, sir. But we have there are some adjustable PR motion sensors, sir, which can adjustable up to 3 meters, sir, and we can even reduce it up to less than 3 meters.
Okay. 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 So you have to do a hardware tuning to adjust it to make sure that it's fitting to your project.
Yes, sir.
Yeah. Okay. Thanks. Thanks.
Thank you, sir.
Suryavardhan?
Yes, ma'am.
Actually, PR sensor will detect all the motion irrespective of human. All the it's called even it detects the movement of animal, isn't it?
I think so. It actually says that it based on the heat it will detect, ma'am.
That's
I
what.
think it will detect the animals also, ma'am.
Yes, it detects animal also. It detects all
ma'am.
the features
Human
of
living
organisms.
beings.
Yes. Okay, so then
Yes,
how your system is going to identify whether it is a human or it is going to be an animal? Are you doing any
Ma'am, even
identification
to
mark for this?
we didn't come across this thing, ma'am. But we even though from animals also we can there's a possibility of getting coronavirus, ma'am.
So your focus is that irrespective of human, if anyone could spread it,
Yes.
they will come under your category.
Yes, ma'am. Living being, ma'am. Based on living being.
Okay, fine. Proceed, sorry,
Thank you.
Thank you. The next team.
Ma'am, I'm ready, ma'am. Ganesh.
Yes. Who's ready?
Ganesh and Shravan, ma'am.
Okay, Ganesh.
So Ganesh will present PPT, ma'am.
Okay.
Ma'am, few seconds, ma'am. Ganesh is facing data issues, ma'am.
Okay. Okay, if next team is ready, even they can present.
Ma'am, can I present in the meeting?
Yes, Abhijit.
Okay, ma'am. Ma'am, can you see my screen?
Yes, we are able to see it.
Okay, sir. So my project title is Smart Water Management System. And what I'm planning to do is see with the recent development of internet, we have so many sensors available, cheap sensors available in the market. So I'm trying to incorporate all those sensors and make a water quality management, water quality detection system that detects the quality of water services, quality of water in like any given like a tank or any given platform like that. So what I'm planning to do is integrating IoT concepts into these devices, and then creating sufficient water quality addressing system. So so the main problems we face in the water system, like even in the industrial or even in the domestic situations, the main problem we face is that overflowing. Even when we switch on the motor, if we we are like engaged in some other works and it starts overflowing, so we wouldn't notice, and there is a lot of loss of water. And then even in industry, such cases can happen, and sometimes it could be like fatal. Sometimes even small leaks in industries can lead to catastrophic damage. So to prevent all that, I have tried to make a system that addresses the quality of water. So here is my problem statement that what the existing system has in store for us, or what is available in the existing system. So the existing system cannot detect the dissolved contaminants such as chemicals. We can actually detect the rise in water level or the depth or such things like that, but it cannot detect the dissolved contaminants such as chemicals. So what I'm meaning to say is chemicals such as water we get especially in India is chlorinated. It has a lot of chlorine in it, and a lot of chlorine is not good for health. So it is not practically possible. Actually, it is not possible to some extent to measure the exact amount of chlorine in parts per million or such. In such ways, we need a very rapid and high technology for that. But a factor that overlooked sometimes is the pH. So if chlorinated water has a certain amount of pH, or if given if the water has some other chemicals, then the pH may vary. So it's a factor that we overlook at sometimes, and it is very important. So we can measure the pH of water, and thus we can conclude that what kind of nature the water has. Like if it is too much chlorinated, for example, chlorinated water has a pH varying from 7.5 to 8.5. So if it is between that pH, then we can conclude that the water is kind of chlorinated. And if it is above 9, and then we can conclude that it has some other kind of chemicals dissolved in it. So by addressing a popular data sheet, or concluding from a data sheet, we can address what kind of chemicals are dissolved in the water by just looking at the pH. And another important factor for the quality of water is its temperature. So sometimes we require warm water, sometimes we require cool water, even for drinking purposes. So the temperature factor of water is very important. And last but not least, I have the depth. I don't call depth, but the overflowing factor. So we have to prevent water from overflowing, because it is very, we have posters, even posters stuck around there, like it says that stay water, and so much even campaigns are going on now to save water. So we have to prevent overflowing by any means possible. So the third factor I'm looking into is overflowing. So here are the ingredients that are needed for this project. It's a very simple project actually. So we need Raspberry Pi, specifically Raspberry Pi 0 watt. Excuse me, ma'am. Okay, so Raspberry Pi, and we need an ultrasonic sensor, jumper wires, mobile devices. Not just ultrasonic sensor, we need a lot of variety of sensors actually to address the quality of water. And we need a device which could be possibly mobile, preferably mobile or maybe laptop, doesn't matter. Then water quality or pH sensor and temperature sensor. And the software platform is given as this, like Node-RED, Raspberry OS, JavaScript, and Wi-Fi modules. So this is the basic architecture. And we have water quality sensor, which is basically our pH sensor, flow sensor, water level sensor, temperature sensor, and this is the power supply. This is the voltage that is supplied to the Raspberry Pi module, and then that Raspberry Pi is connected to the cloud database and to the web interface, followed by the web interface, and followed by our water, and it will display the output of our water quality. And this is basically the proposed framework. And here, as you can see, all the required sensors, the water level sensor, quality sensor, water flow sensor, and temperature sensor are all connected to the Raspberry Pi 0 watt. And a power supply is a supply of 5 volt. The supply of power is given here, and it is connected to the web interface, as you can see in the diagram. So this is the like a brief description about the different sensors used in the project, and we have, like as I have already mentioned, the water quality sensor, water level sensor, temperature sensor. Actually, temperature sensor is a device which gives temperature measurement as an electrical signal, and it basically works like that. And the signal can actually be as in form of like electrical stuff, like electrical voltages or such sort of stuff. And then we have cloud, and we have a Raspberry Pi module. So I'll be demonstrating the flow for but unfortunately I don't have the hardware components, especially this Raspberry Pi and these sensors. So I have done the software simulation in Node-RED. And this is my first flow, which measures the level of water, and I'll just display the output here. Sorry. Okay, deploy. See, if I've connected the required probes and the required sensors to the Raspberry Pi module, and if I have dipped them in a water surface, a tank containing water or some sort of stuff like that, even a small bucket, then it will display the amount filled, because it is an ultrasonic sensor, and as you have already seen that ultrasonic sensors are used to measure distances. So which is basically we can use HCSR004, that is the preferred module, and I have done my simulation. I've chosen that node in such a way that it suits the HCSR04 module, 04 sensor, sorry. And this is the, you can see if actually I don't have the hardware components, or I haven't done any sort of hardware simulation, that is why it is still, if you are actually to do it, then you can see that this what do you call, pointer would rise up and it would display the amount of tank filled. And now I'll show the pH simulation. So here I've shown you the simulation for calculating the pH. So it ranges from 1 to 10, and you have to connect the necessary pH sensor and the pH probe, and then you can actually see if I had gone for the hardware, then you could have actually seen it would have measured the pH inside the water. It would have measured the water pH, and this is the temperature, and this is the temperature measuring gauge, and you can actually see I have set it to 25 units, but you can actually you can actually see what temperature the water holds, or how hot or how warm the water is. So that's all, and concluding about my project, and here you have the applications and all sorts of applications in industrial area, commercial complex. You can use wherever you want, but it could be a little bit tedious and a little bit hectic. I'm not gonna deny that. It could take a while. It could take a while, but you can actually implement this project as a part of smart city with the necessary and sufficient technological advancements and the necessary technological ingredients and stuff. If you have them with you, you can actually do this, but it could be quite tedious and quite hectic for that, as a matter of fact. So thank you so much, sir.
Yeah,
You had somewhere flow sensor also, right?
Sorry, sir.
you had a flow sensor as well, right?
Your diagram.
Yes, sir. Okay, sir. That is actually a kind of what do you call a valve, sir. So you can actually regulate it using an application like Node, but I haven't actually implemented, sir. In the diagram, but I hadn't implemented it.
Okay.
So just to get an idea, what pH sensor would be required?
What pH sensor you're asking, sir?
Yeah, pH sensors, right?
pH sensor. I don't know the exact specification. Really, sir, I really don't know the exact specification of what sensor could be used there. I always about the ultrasonic sensor that model. I don't know the exact pH sensor that could be used.
Okay, because
with this project, I think pH sensor is a little tricky part.
mobile network connect
Design an API that is going to receive this request, and then the API is going to generate an OTP, a random OTP, and it's going to send it back to the web server, example.com web server. And the fourth step is the OTP screen is presented to the user. So now the OTP is generated, it is sent to the web server. Now the user has to actually go ahead and view his secure 2FA device, authenticate with it by inputting his fingerprint sensor or his password or whatever. And then what happens, the user can see the OTP and he enters it in the OTP screen, and then he gets authenticated. So that's the idea. So these are the flaws in the traditional two-factor authentication. As I already mentioned, hackers can actually manage to sniff your OTP. So initially, when you are booting the device, which we are proposing for the first time, what happens is it must do a handshake, so that both the device, as in the client device, and the secure 2FA API agrees on a key. So each device that we are deploying will have a hard-coded S2FA ID. So this is hard-coded and it's unique for each device. So what happens is when the device is first booted, it generates a public-private key pair using the RSA algorithm, and it sends the public key to the secure 2FA API along with the unique S2FA ID that is hard-coded into it. Now the secure 2FA API now generates a 256-bit symmetrical key, and it encrypts it with the device public key that is received from the device, and it sends it to the device. The reason why we are doing is because no one can do a man-in-the-middle attack and sniff the data, because even if they captured the traffic, they would still need to decrypt it, and they would need the private key to decrypt it. So that's why we are encrypting it publicly and we are sending it. So now when the device receives the data, it uses its private key to decrypt it, and the result obtained is the 256-bit symmetrical key, which is generated by the secure 2FA server or the API. So now both the client, as in the device, and the secure 2FA API both agreed on a key, a symmetrical key. So now they can communicate. As in communicate, I mean exchange the OTP. Like the API can send the OTP to the device, but first, before sending it, they can encrypt it by using the key that is agreed. So when it is received on the device, it will have the symmetric key, so it will use that key to decrypt it. So that is our proposal. Now let me show you a simple demonstration which we have done.
So first let me fire up the API. So I'm using Flask to actually create an API. The API is now up. Let me test it if it's up or not. So yeah, Secure2FA API is now running. And we've also created a dummy like a login page like a web server to demonstrate how it communicates with this API and gets the OTP and stuff. So let me start that as well. This is the dummy login page. The two-factor authentication is enabled on this page. So let me give some credentials. These are the dummy credentials just for the demonstration. So when I click on sign in, it takes me to this enter OTP page wherein I have to enter the OTP. Only if I enter the OTP, I'll be given access to my account. So let me go to my Node-RED. We're simulating it using Node-RED. So this is basically the device. It has only two buttons. The first one is get OTP, and the second one is clear or reset. So get OTP, it will fetch the OTP from the Secure2FA server. So when I click on get OTP, it displays the OTP. So this is the OTP. Let me show it to you on this website. So this is the generated OTP 9247. The same is displayed here as well. So if I try to enter like any random OTP, it doesn't give me access. It says wrong OTP entered. Please try again. So I have to enter the exact same OTP. Let me copy this OTP here. If I enter and if I click on confirm, it gives me access to to my account. So what actually happened here is when the dummy website, I made a login request to the dummy website. It's going to send a request to my API. It's going to send a request to my API asking to generate an OTP. So the API is going to generate the OTP and it's going to send that OTP as a response back to my dummy website. And it also is going to store it in a database. So when we are clicking on get OTP here, the device is actually making a request to the API and it's going to send its ID, the unique ID. So based on this ID, it's going to identify the device and it's going to retrieve the saved OTP from the database and it's going to send it back to the device in encrypted form, and the device decrypts it and it's going to display on clear reset so access it anyway. So yeah, that's it, sir. That's our implementation.
Yeah. Okay. Yeah, I understand this two-factor authentication. What are the other use cases where it can be used in any corporate sector or anything? You have thought about it?
Actually, if you want to make it release it to the market, we would need to contact. Let's say we want a website, for example, example.com to use this thing. So they will have to actually communicate with our API. So we have to actually get in contact with them. We have to tell them how our idea, and only if they accept it, they'll be able to create a communication with our API, and only then they can do it.
Okay, no, my question was not that. My question was in the current, if you take the authentication mechanisms, you would have Active Directory systems, which is
yes, we can use it in banking systems, sir. First and foremost thing, because it has to be really secure banking systems. And there are many cases where online banking frauds are occurred, and hackers making the transactions impersonating the actual user. So we can use this to avoid that.
Okay, but your problem would be that they need to handle a new device. They have to carry a new device all the time, is it?
Yes, I don't think that would be a problem because it will be a very small device, and just like how you would use a pouch to hold your mobile, we could attach it to the pouch. It's going to be a really small device with just a screen and a small fingerprint sensor. So it just displays the 4-digit OTP. That's it.
Okay.
So yes.
Yeah. Good idea. Thanks.
Thank you, sir. Thank you.
Yes, Tejaswarup. Could you hear me? Hello?
Ma'am, we can't hear you.
You can't hear me? Hello. Okay, next team, you can proceed.
Or written text into the audio output, sir. We use OCR devices. The, it gives audio for the existing language in that book, sir. OCR systems are already in use for many languages. This is the existing system, sir. This paper presents a method of design a text-to-speech conversion module by MATLAB matrix operations. Firstly, by the use of microphone, some similar sounding words are recorded using a record program in MATLAB window. Then recorded sounds are saved in .wav format in the directory. The recorded sounds are the sampled and unsampled values are taken and separated into their constituent phonetics. Problem statement. Traditional methods is like Braille exist using the blind people have to trace and read the text. So it is very tough and it's very slow. So we use this. OCR systems are not automatic and require full-fledged computers to run and hence not effective. We use ultrasonic sensors and ROI detection for text localization algorithms. If the person hold a book, it will tell the name and printed text in that into the.
Okay.
It transfers the text to audio output, written or printed text audio.
Okay. Okay. So, what would be the other things which are needed in this project other than just the reader? And this is more a client side, right? You would need a server or something where you need to store all the audio clips and things.
Audio clips is written in the MATLAB, sir. You can use MATLAB and.
Okay. 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 Yeah. Thanks.
Thanks.
Yes, thank you, team. Next team. Hello, am I audible?
Can I proceed now?
Yes.
Yes, Javeri, proceed.
Ma'am, can you see my screen?
Yes, we can see your screen.
Yes, we can see.
My project is on smart farming. Here, farming is the broadest economic sector and plays an important role in overall economic development of nation. So technology advancements in this arena of agriculture will certain to increase the competence of certain family farming activities. So the main objective is smart IoT based on live data like temperature, humidity is a widely spread.
Hello. நிட்டி ஏன் இன்னைக்கு நான் படுத்ததுன்னு தெரியல பேபி.
So this is the front end of controlling the. This is the front end for. I've implemented the idea of where you can open Chrome extension and use file browser for everything. Doesn't need internet, but in this case, we go and download and delete. So this is the part where it connects to a server where you can. I have set it like you can connect to 4 servers. For example, one would be your home Wi-Fi, one would be your office Wi-Fi, one would be your personal mobile data. The problem with this scenario is that if someone gets we can select files. This is upload file from STM side. ESP side. So this is it shows the file name, what to upload. It shows whether if there is a previous version, like there should be no redundancy, so it checks for redundancy, and then if there is not, then it creates. If there is, it shows that there is a file already existing, and then if a file is uploaded, it shows that the file is successfully created. So this is the SD card directory. Like I said, it allocates everything and keeps just like I said, Chrome extensions. This uses just like Chrome extensions as we see Node-RED and command prompt, right? The same idea. We use this for allocations. This is printing directory for printing something in directory, for allocating new stuff inside, or erasing and updating the directory. So we've allocated according to the size. I have allocated according to the sizes, like if it's less than 1 MB, less than 1 GB, or less than 1 TB, and so on.